Hello dear students, this is Dr. Sourav sir's class. We are now solving our UPSC 2024 Mathematical Optional Paper from our year 2024, yani this year. So, the question says us to solve the partial differential equation which is given as our del by del y of del phi del x plus phi. Okay. Plus our 2x square y of, into our del phi del x plus phi is equals to 0 by transforming it to the canonical form. Okay. So what can be done? So we are now tasked with solving the problem, given problem, which is our partial differential equation, this and okay. Now, firstly, we can do this. Take our u b. Yeah. So now substituting our u into the equation, we will rewrite the partial differential equation as it will be our del u del y plus 2x square y of v into u plus 0. Yeah. Now we can see that this is our first order linear PDE in our U. So what will be the second step of this? We can rewrite this as our del y del U will be our minus 2x square y U. Then U will come this side, so it will be this. And now if we are integrating the both sides, then we will get our, and minus of 2x square y dy. Then what we will get? Then this will be ln mod u and it will be minus 2x square will move outside. So our, as our y dy is equals to, we all know it will be y squared 2 plus something, then it will be y square plus c1, let it be the integrating constant. So now it will be our u mod u, or our u is, that 2 will come down, so it will be our c2 e to the power minus c square y square. Our e to the power c1 be c2, that's also a constant now. So now we have to back substitute it for u. Okay, this font size is also good. So now we are back substitute it for u, then what we will get? Then it will be del phi del x plus phi will now our c2 e to the power x square minus x square y square. This is also a linear first order or ordinary differential equation for phi in terms of x. Now we have to solve it. So what will be our integrating factor now? By the auxiliary equation we can write it as m plus 1 Sorry, we don't need that. We can easily see that our e to the power x will be the integrating factor here. Yeah, it will be our e to the power x, and it will be this. Yeah, okay. Am I doing something wrong? Okay, let me take it as c1x be an arbitrary function of x. So now this will be also a function of x. That means it will be our c2x. So now, yeah. So now I am where? Okay. So plus there will be, now there will be nothing. But after integration there will be something. So we can see that it will be our del x of e to the power x phi as, yeah, because our this thing is goes to this as our del x of e to the power x is e to the power x, and first in the first case the partial derivative will appear for phi, and after that it will be go to e to the power x. Then let it be ours this. Yeah, that's okay. So now equals to our e to the power x minus x square y square. So again the integration happens for the both sides, so it will be our e to the power x phi, and it is our c x e to the power x minus x square y square, then plus c of y occurs, which is a constant of integration with respect to x, constant of integration with respect to x. So it can be a function of y also. So now our phi of xy will be e to the power minus x whole common c2x e to the power x minus x square y square plus cy. Okay. So the solution has been transformed in this form, and our c2x and cy, yeah, okay, and this is our required solution, and our c2x is function of x, which came for the constant of integration with respect to y, and our cy is the function of y, which is a constant of integration with respect to x, which is there. Okay, hope you understood. Yeah. These are the calculations to get this big thing. Okay. Thank you guys. Hope you understood, and this is our correct. This is our answer for the question. Okay.